Okay. Sorry. Benda tu, you know, sometimes it doesn't happen that often. But sometimes, saya punya komputer ni, dia disconnected. Oh, I got to start.
ওই রুম যে রুমে খাতা টাতা বই খাতা এইগুলো দেখে এটা লাগাবে এই দরজা দিয়ে আসো পিচ্চিটা ধরে তারপরে
Okay. Continue. We continue. All right, go back to the figure. Now, for that figure 1.22, what can you say about the solution? Okay, what can you say about the solution? Okay, go ahead. Look at the question. The figure, 1.22. What can you say about the solution? Anybody? Just look at the graph. You know, what can you say about the solution? Because you have three situations. You know. Okay. Figure 1.22. What can you say about the solution?
Sir.
Yeah, go ahead.
Based on the first graph, the figure 1.22, the solution there's a solution between two equations.
There is a solution.
It's shown by the intersection between.
So that is the solution. Okay, the intersection point is the solution. Right. Okay. So there is only what? Here you got a unique solution.
Only one solution, sir.
Only one solution. So unique solution means there is only one solution.
Yes, only one.
So if there is only one solution, you call it unique. Okay, unique or only one.
Okay, sir.
Okay, that's one possibility. Now you look at the second figure, 1.23, the first one. All right, you'll see the two lines. Now, is there a point of intersection? So case number one, you may have a unique solution. Number two?
No intersection.
No intersection.
There is no intersection, right?
No solution.
There'll be no solution. Okay, no solution because the line do not intersect.
Do not intersect.
Yes. Okay. All right. What did you say? I was talking.
Many solutions.
The third situation here, you got two equations with the same form. Two equations with the same function, with the same constant, same x, y-intercept. So case number one, you have infinitely. Okay, there are many solutions. In fact, there are infinitely many solutions. So this is the possibilities. Now, the one that we are interested in, like I said earlier, we are interested in looking at situation where we have only one solution. So this one is the most important. All right. If there is no solution, then we cannot move on. Because again here, if there are so many solutions, doesn't solve our problem. So we are interested in only number one. Now, for a unique solution, let's look at the system. Let's say I have one m1x plus b1, so call it equation number one. And then I have another linear line y equal to m2x plus b2. We call it number 2. Okay. For a unique solution, for number 1, we need only to look at the slope. If the slopes are not equal, then you have a unique solution. So when you solve the problem, a system, okay, you just look at the slope first. If the slopes are not equal, then you have a unique solution. If you have the slope equal, then it's either what? Either you have no solution or you have infinitely many solutions. So you are not. So we don't worry about the second case and the third case. So anyhow, let's look at a case. All right. If you have M1 equal to M2, the slopes are equal. All right. But the intercept are not equal. You see the slope, they are the same. Okay. And then the intercepts are not the same. So will there be no solution, or will there be infinitely many solutions?
No solution.
There will be no solution, because here you got just parallel line. Okay. So if you got this thing, it's just parallel. The lines are parallel because the intercepts are not equal. So that will be number 2. Now, if you have both the slopes equal, the slope equal, the intercepts are also equal, then what do you got? That we go where? That we go to number 3. There is only the one possibility left. So you have the 2 equations have the same equation, or the 2 functions have the same equation. The slopes are equal, intercepts are equal. So basically the 2 lines are the same. So therefore you have infinitely many solutions. That would be like the figure in 1.23b. So like I said earlier, the only case that we are interested in, if you have unique solution. So one way to look at unique solution, just look at the slope. If they are not equal, then go ahead, solve it. If they are equal, then you look at the intercepts, okay? It can be either no solution or there are so many solutions. Okay, any question about this? Okay, next, we want to look at a method of solving the system. Now, the method that we are going through would be simple method. That is the method of substitution. We just use substitution method, okay, to solve it. So you go back to the equations in the system that we have. Y equal to M1 plus M1x plus B1, that is number 1. Y equal to M2x plus B2, that is number 2. So what you do, you simply substitute, because they are both y in terms of x. So you just substitute one into the other. Okay. So let's say we substitute 1 into number 2. Correct? So you got what? M1x plus B1 equal to M2x plus B2. That means you substitute 1 into 2 for the y, lah, okay, for the y. So now you solve for x. Solve for x. So let's say I got x, call it x star. Next, you want to find y. Okay, you need to find y star. So what do we do? Again, substitute. X equal to the x star that you got above into either 1 or 2. It's up to you, you know. So you can choose number 1, you can choose number 2. Then what you get will be y equal to y star. So you got the solution, x star, y star. That will be the solution. So the method is substitution. And we do the substitution 2 times, double. Okay, of course, this one, I would like you to go home and try to do this solving in terms of M1 and B1. It's good practice, you know. You bring the M1, you factor out the X, and then you put the M together, and then you bring everything to the every constant to the right. You got X equal to something, and then substitute into 1 or 2, you'll get the Y. So good practice. So I want you to go home, try to do it. All right? Okay. Now what I would like to do, we will do example. So we just do an example, okay, of a system that you want to find the solution of. Say, I have equation y equal to negative 5x plus 12.7. That's call it number 1. And then I got another one, y equal to 2x minus 20. Or too many 2. So replace the 2, you know, with other numbers. I got so many 2, so here negative 3. Ya, ini kita tukar jadi negatif 3. Okey, hot ni pun kita tukar jadi benda lain. Negative 3x minus berapa? Minus 9. So that we call number 2. So how to solve it? We substitute. Okay, find the solution. So that is the question. Okay, find the solution to the system. So you substitute. So we just substitute 1 into number 2 or 2 into 1. It doesn't matter, same thing. So you have negative 5x plus 12.7 equal to 3x minus 9. So you bring the x to the one side, you bring the constant to the other side. What I got will be negative 5x minus 3x equal to negative 9 minus 12.7. So this one is easy. Negative 8x equal to negative 21.7. Negative. So therefore, x is equal to 21.7 over 8. Because negative and negative become positive. So berapa dapat?
2.7125.
2.7125. 125. 271 kuat. Okay. 2 decimal point. So that is, we call it x star. So you got already the solution. In particular here, the value of x. You got only half of the solution, okay, the value of x. So next, you want to find the value of y. So you substitute the value of x, which is 2.71, into either 1 or number 2. It's up to you. You know, you pick up your choice. So I want you to find y. So some of you substitute into number 1, some of you substitute into number 2. I would like to see what y do we get. Okay, finish it up.
Negative 0.085.
Negative?
0.085.
5 for equation number 1.
Negative?
0.85.
Negative 0.85. So you got this. So what you do here is we substitute x star equal to, so I just write down the value. I forgot the value, 2.71. Okay, 2.71 into number 1. So you got this. Now, anybody did for the equation number 2?
Negative
Negative
0.87.
0.87.
Very near, okay, very close. Because maybe I round up to 2 decimal points. If you want to see a more closer answer, make it into 3 decimal points. So yeah, maybe it was a good idea. We use our initial 2.713 kan. Probably if I put another decimal point, the point will be closer. So that's you put into 1. Now, if you put into 2, all right, into 2, you'll get y equal to negative 0.87. So
Yes.
you see very close, okay? Why difference here? Because of the decimal point that I choose, you know. If I put more, then it'll be closer lah. So acceptable, right? So acceptable because it's not that far unless you get y equal to 1.5. Okay, then I think something wrong lah. Okay,
Okay, sir.
so that's good. So either you put into 1 or 2, you will get the same value of y. Okay, here you got different due to the decimal points. All right? Okay, good. So that's how. Now, suppose, you know, in some cases, you are given the general form. Okay, you are given the general form. Like in the book, they give you x. Let's say they give you 2 plus 3y equal to 20. That is number 1. And then you got 5x minus y equal to 5 equal to 6. So don't worry about the form. Okay, it can be general form. What you do again here, you substitute. But there is extra step. You know, there is extra step that you do in order for you to be able to substitute. That means from 1 and 2, you have to write y in terms of x or x in terms of y, then substitute into the other one. So method is the same, but you have to have one extra step. That means step number 1. Okay, step number 1 would be you write, okay, from 1 or 2, you get y in terms of x. So say here, the easier one will be from number 2. Okay, from number 2, you'll get y equal to 5x minus 6. So you got this, call it number 3, and then substitute into number 1. So if you are given general form, method is the same, all right? Just that you need to do one extra step. You have to write y in terms of x, or, okay, or not necessarily in terms of x, because you want to stop only for the solution. You can write x in terms of y, okay? X in terms of y, that also can be done. So it depends on which one is easier to do, okay? And then substitute. So that would be the system. And I will give you some questions, all right? Homework question. On 1.5, there are some questions you got from 5 to 8. Okay, so do number 5 and 8. And then you do question number 9, number 10, and then number 12. But one thing is good, you know, that for these questions in the book, they give you general form. But like I said earlier, if you want to know whether there is a unique solution or, you know, no solution, you want to look at the slope, okay, M1, M2. So it is good, just a good exercise for us, that for the system in general form, before you solve it, just rewrite, okay? Rewrite into the slope-intercept form. Correct? In other words, y equal to mx plus b. So that you can look at the slope. If the slopes are equal, then you just say, you know, if the slopes are equal, then you look at the b. Then you can say whether there is no solution or there are infinitely many solutions. So you don't have to spend time trying to solve, because if you do that, you will go back and forth, you know, you got no solution. So it is good that you write the equations in terms of slope-intercept form, so that you can make the comparison for the slopes to determine whether you have solution or no solution. So that is for 1.5. Okay, 1.5, like you to do those some questions. Okay, good. Okay, any question, any comment about that? Okay, if there is no comment, I want to move on to 1.6. Now, 1.6 is the application of the system. Okay, application of 1.5. So there are two applications that we are going to look at, mainly, you know, business and economics application. Number one, we look at break-even problem. And number two, you have a look at market equilibrium. Okay, market equilibrium problem. This is demand supply. That is economics problem. So let's look at break-even. Okay, look at break-even. What is break-even? So what is break-even? I would like you to just read the first part of that 1.6. Okay, we need to read the revenue, profit, and the cost. Okay, go ahead, go through that, and then we will discuss. Break-even. What is break-even? Okay, break-even. What is break-even? Okay, break-even is the following. Break-even meaning what? Meaning the profit. Okay, the profit, call it P, equal to 0. You know, your profit equal to 0. So what does it mean? It means that the revenue that you earn from the sale of your product is just equal to what? It's just equal to the cost of producing that product, or the cost of acquiring the product. So that is called break-even. So in other words, profit equal to 0, and then you have to relate to the revenue and the cost. So therefore, we define profit. Okay, what is profit? Call it P. And that P is a function of X. Okay, function of X. X is our units, that is our output, or the product in terms of unit. Okay, so the profit will depend on the sale. Okay, sale of X and the cost of X. So profit, which is a function of X, is equal to the revenue that you earn, and that is a function of X, minus the cost of producing the good or the product, or the cost of acquiring the good or the product, also in terms of x. So you got P of x equal to R of x minus C of x. And for break even, okay, for break even, what is the requirement? For break even, the profit is 0. So therefore, P of x is equal to 0. All right. Now, when P of x equal to 0, what does it mean? It means the revenue minus the cost is equal to 0. So revenue equal to cost. So there are two ways of doing this question of break even. Number one, we can do it right away from the profit, which we know profit is equal to revenue minus cost. Look at the profit, you said equal to 0. Or number two, you do it by using revenue and the cost, you equate them, and then you got the x. Okay? So there are two ways of doing it. It's up to you which one you like. But I like, if you just want to determine break even, you know, I think I prefer the direct method. You get the revenue minus the cost, which is the profit, and then go from there. Or if you like, you can also do it from here. You get the revenue, and then you get the costs, equate them, you get also the break-even point. So the solution will be the X star. And that's what we call the break-even point. Okay, break-even point or the break-even X, whatever the X is. But normally we're talking about output level, output, you know, in the units. So it's the break-even of the output in terms of units. So that would be what we mean by break-even. Okay, any question? Okay, that's definition. Now look at revenue. What is revenue? Revenue, which is a function of X, or in short, we know it's a function of X, so we just write revenue. Now, what is revenue? You know, revenue is your income from the sale. Now, how do you get that revenue? Suppose you are selling a product, you know, how do you get the revenue? How do you compute the revenue? How much you get? Ini ada dalam 1.6 kan?
Price unit times unit.
It's just what? It's just the price multiplied by the quantity of your sale. Okay, so you got P times X. Say, okay, example. Let's say the price. Let's say you are selling what? Give me a product that you sell. You sell. I know some of you doing part-time business. Anybody doing part-time business? What is the price of your product? Give me the price. Suppose you are selling, you know, shoes. Okay, I know some young people, you know, selling shoes online. Suppose the price is for the same model, you know, about same. Let's say the price is 100 ringgit. And the amount that you sell is 50. So what is the revenue? Revenue will be 100 times 50. Then you got 5,000. So that will be your revenue, 5,000 RM. So the unit will be in RM, right? So revenue unit is in dollars or RM. X in terms of the unit of the good. Now, what about cost? Okay, cost is not that simple, you know, because revenue, you get this. Cost, here we are talking about linear cost function. Okay, linear cost function. So again, we know, okay, linear function is what? Mx plus b. So therefore, for the cost, you will get mx plus b, which is exactly equal to, if you go to the concept of the cost, okay, cost, what are the components of cost? Anybody recall from principles of micro?
Fixed cost, fixed cost
Fixed
and
cost and
Variable
Variable
cost
cost.
plus fixed cost. And now
Yep.
fixed cost is the cost that you incur even though you don't produce upper level. So that is the cost at x equal to 0. You don't produce anything, you incur some cost. That cost is called fixed cost. So that fixed cost is B. All right? That means it's the y-intercept. So you call here C-intercept. The variable cost is the component of the cost that depend on X. Okay, so this one here depend on X. The more you produce, the higher the cost. All right, so that is the variable cost, the component of the cost that depend on X. So that will be that component here. So mx plus b is in fact just equal variable cost plus fixed cost. For revenue, you don't sell anything, you get nothing. So if you relate back to the mx plus b for the revenue, b is 0, okay? Because that is the y-intercept for revenue. That means the r-intercept. In other words, if I don't sell anything, I will get nothing. I get 0 revenue. So therefore, that b is equal to 0. You will get just linear function like that, with the intercept equal to 0. So that is our linear function, okay, for the revenue and for the cost. Okay, now, next, we want to look at the slope. Okay, the slope, as we recall, is the m equal to what? Delta y over delta x. Okay, that's general form. Now, for revenue, that is equal to P times X. So what is the slope for the revenue? So for the revenue, the slope is equal to delta R over delta X. Okay? Now what is the slope? Equal to what? Look at this one. Slope dia mana?
P.
The slope is P. Okay? So the slope of the revenue function is the price. Now, what do we call the slope of revenue? Delta R over delta X. We call it marginal revenue. Okay, marginal revenue. Now look at the cost. Cost is mx plus b, which is the variable cost plus the fixed cost. And the slope is equal to delta C over delta X. And what is it equal to? Inilah dia. Equal to what? Equal to M. So that because you use M. If you use another symbol, then we equal to that thing. So we call this marginal cost. Okay, that's marginal cost, and that is the marginal revenue. So definition of marginal revenue, marginal cost, that comes from the slope. Okay, so the marginal revenue, call it R. What does it mean? It means the change in R, or I think I will go more specific. Let's say the M price, of course, the price is bigger than 0. So that means your revenue will increase by how much? Will increase by the amount of the price, okay, by P. Okay, by P units, whatever the unit is, normally it's in dollars lah. Per unit increase in what? Per unit increase in X. In other words, if I sell one more unit of the good, my revenue will increase by P units. All right, so that is marginal revenue. Now, similarly for the cost, all right, normally the marginal cost, that would be equal to the I think I'm going to write another sentence. So the marginal cost, okay, MC, that is the slope of the function, is equal to what? MC is equal to delta C over delta X. In other words, the M, okay, the M, that's the marginal cost. That means the cost would increase by how much? By M units per unit increase in X. So in other words, the cost will increase by M if I produce, okay, produce one more unit of the good of X. So if I produce one more unit of X, the cost will increase by M. Now for the revenue, it's similar, but we are not talking about production, it's about sale, okay? If I sell one more unit of X, the revenue will increase by P, and P is the price. Okay, okay. I'll give you an example of revenue. I don't give. So let's say the marginal revenue, or the slope of the revenue function, is equal to 100. Okay, 100, like what we have earlier. So what does it mean? It means, okay, and of course that is the price, okay? So that means if I sell one more pair of shoes, okay, if I sell one more pair of shoes, what is the increase in my revenue? Hello, 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 are you there? If I sell one more unit of shoes, one more pair of shoes, because we're talking about the example of shoes, what is the increase in your revenue?
100.
100. So that marginal revenue is the increase in your revenue per unit increase in the sale of your product. So if I sell one more pair of shoes, you know, that is for our example, then your revenue, okay, our revenue would increase by 100 RM, which is exactly the price of the good. All right, the revenue will just increase by the price. So for the marginal cost, I'll give you example, the marginal cost, M here equal to 65. So I want you to interpret, all right, by this definition. If I sell one more unit of the shoes, one more pair of the shoes, what about my cost? Okay, what is the increase of my cost? So I want you to finish it up. So that is break even. Okay. So how do you find the break even? You will set profit equal to 0. So let us look at an example. We know the revenue. All right. Suppose we are talking about the shoes. You know, your example, the shoes sale. You want to find the break-even point. Okay. Break-even quantity or the pairs of shoes. That means how many pairs of shoes that I have to sell in order to break even. So we know revenue equal to 100x. The cost, I give you the marginal cost was 65x. Say our fixed cost equal to 73. Suppose we have this, all right? Now I want to find the break-even point. So what do? You know, okay? We know the break-even is what? Break-even is where the profit equal to revenue minus cost equal to 0. So that is what we know, and you want to find X, okay? Where P is equal to 0. So that is what we want to find. So we write the profit function. So therefore, the profit function will be equal to what? Will be equal to revenue minus cost. Revenue is 100x minus the cost, which is, I think we have to write down the negative sign clearly. Minus 65x plus 73. Okay, now finish it up. So that is the profit. Okay, now for break even, profit is equal to 0. All right, so therefore, this revenue minus cost, of course, you can simplify, equal to 0. So finish it up. What is the X? Okay, finish up. Can you do it quickly? In 1 minute. Not 1 minute lah, in 2 minutes. Finish it up. Dapat dah?
I get 2.08.
2.08 pairs. Okay, anybody get another value?
No, I got the same.
Same. So that means that's correct lah. Okay. If many people got the same, most probably that's correct. Or we may have a case everybody is wrong. So what you do here, we know the break even where the profit is equal to 0. So I have 100x minus 65x minus 73 equal 0. I break down the bracket. So again here, I know I just want to remind some people, when you break down the bracket, make sure you be careful with the signs, all right? So here positive becomes negative, positive here become negative. That will be 35x equal to 73. So x is equal to 73 over 35. That is 2.08. So in other words, about 2 pairs. So that is the break-even pairs of shoes. You call it X star. So you say, to break even, we have to sell 2.08 pairs of shoes. So if you want to round up, that will become 2 pairs of shoes. Okay. So our conclusion would be to break even you have to sell 2.08 units of shoes, and the unit is in terms of pairs of shoes. And of course, you can find, all right, you can find what is the revenue, which is equal to the cost at x equal to 2.08. Okay, you can do that. So I think that will do it for today. We need to have at least, half an hour, because I need to finish up another application that is on the market equilibrium. So that will take another half an hour. So by next week, Monday, half of the period, I want to finish up the linear function, the application on the second application. And then after that, we will move on to topic number 2, which is linear programming. So next week, we will go to linear programming. Okay, the topic on chapter number 4. Okay. I think number 4. Yeah, chapter 4. Okay, so I will give you before, for the weekend. I think you need to practice some questions. So for the break even, okay, this is done on the break even. I give you some questions. I want you to discuss with your friend, okay? Don't do it by yourself. If you're not sure, you ask your friend, or you post your question in the group so that I can see, I can also respond, and your friends can respond. So make full use of the WhatsApp group. Okay, so I would like you to do some question. Okay, okay, do number, this is 1.6. Do number 2. Okay, number 2, this is on the stereo. So if you have a different edition, probably your question will be, on another topic. So number 2 is on the stereo. Number 3 is on the ceiling fan. So if you have another edition, the question are on, question is on a different number, do that number. Okay. I want you to do number, siapa contoh ni? I want you to do question number 13. Okay, 13, the extreme production. I'm sorry, extreme, bukan production, protection. Okay, and then number 16 up to number 19. So a good question, good number of questions for you to practice. To make sure we are able to, we understand the concept, break even, the marginal revenue, the marginal cost, we can solve the system. Okay, so this will not be very difficult. Now, any question, any comment before we go?
No, sir.
No,
Okay, good.
Sir.
So I will see you again next week. Have a nice weekend. Take care. Okay,
Inshallah.
the COVID-19 cases are getting more
Worse, sir.
worrying, especially Selangor. If you are staying in Selangor, take care. You are staying in Kedah, but as of now, I think the area in the East Coast, Pahang, Terengganu, Kelantan, quite good. But we have to take care. So I'll see you again. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Thank you.
Thank you, sir.
Thank you, sir.
Yes, sir.
Okay, thank you. I'll see you.
Thank you, sir.
Thank you, sir.
Thank you, sir.